term, blah, blah. So this is your Pascal's triangle, as we noticed before. Today's lesson we're finishing off L2, finding the binomial coefficient using this lovely formula that's full of factorials. So totally full of factorials. And in a way, lesson 1 has kind of like already given you an idea of what this and this is as well. Like, remember the bottom of lesson 1s, you were doing questions like that. Yeah, so this one, as I said, this one here is like lesson 1. These are, sorry, lesson 3. So from lesson 1, these things are like what lesson 3 is like. These ones are what like lesson 4 is like. Lesson 4 is just when you're finding a single term in the binomial expansion as opposed to doing the entire thing. So you've already got a head start on everything. Last time we had a quick look at this formula. So remember sometimes this, what does this mean? That's another way we can write this thing here, N over R. Like our calculator. Yeah, NCR is right. Yep, we can write it as NCR. In the old school textbooks, how did they also write it? They wrote it as C, an N, and an R down here as well. So I tend to see it written more so like this. You can also see it written as NCR sometimes. So this might be important, kind of, we were just practicing before what factorials are, even to begin with. 6 factorial, 6 times 5 times blah, 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 720. This is an important thing for today's lesson as well. N factorial, the guy suggested would be n multiplied by its previous term, but multiplied by 2 less than n, and so on, dot, dot, dot. You could just write n minus 1, n minus 2, and then dot, dot, dot. That would be fine, because we don't know how big n is anyway. Maybe it's less than 5. Then we were asked to try to work out, using our graphing display calculators, our TR-84s, something like 9 factorial, and you found 2 different ways to do that. So you could enter 9 and then press math, go across to probability and find the factorial button, or you could press 9 and then alpha F2, which is where the window button is, and factorial. We found 2 ways. It might even be a third, we don't know. So in lesson 1, you learn how to use Pascal's triangle to find the coefficients used when doing binomial expansions. Basically, like, you realize that the coefficient to begin with is like the numbers from a single row on Pascal's triangle, like 1, 3, 3, 1, or 1, 4, 6, 4, 1. For example, x minus 2 to the power of 4. So we'll just do this as a little quick warm-up. Basically, this is a little quick warm-up of what we did already. So the exponent is 4. What is our value of a in this case? Or what's x? Not what's the value of a. A is x, sorry, is what I was meaning to say. What is b in this case? Negative 2, good. And our exponent is 4, which means how many terms will there be in the final expansion? 5, yeah, it's always one more. So the fourth row, so therefore what numbers from Pascal's triangle should we use if we need 5? Yeah. Yeah, we don't use 1, 3, 3, 1 because that would only give us 4 terms in the end. 1, 4, 6, 4, 1 is what we're going to use because that's going to give us 5 terms. So we're just practicing revising what we did in lesson 1. So now let's use this to complete the binomial expansion of x minus 2 to the power of 4. Remember, powers of a are descending from left to right, powers of b are ascending from left to right. So you can go ahead and do that if you want. If you've done it already, feel free to just hang out and watch. Properly calibrate. And properly calibrate. Knock that out. And the negative term. nothing you check, is just that your exponents add to a 4. So it's, in the first term, it's x to the 4. Second term, 3 plus 1 is 4. Third term, 2 plus 2 is 4. 1 plus 3 is 4. And it's 4. So x to the 4. Is the next term going to be a positive or a negative? Yeah. Yep, negative 8 x cubed. Negative 2 squared. We probably got this being positive. So plus 24 x squared, which times that by 6. And when you cube a negative, you probably realize you get a negative number. Is that fine? I'm going to put a boo-boo here. What's my final term? Should be, what should it be instead? Yeah, not 8, 16. I did the same one last time, didn't I? 16, yeah. Oh. 16. So you would then check, have I got descending powers of x? I got, like here I had ascending powers of negative 2. I've got 5 terms and all that business. So that's the binomial expansion of x minus 2 to the power of 4. Any questions about that? That was just a warm-up kind of what we did in lesson 1. In lesson 1 you also learnt how to use your GDC to find the values of Pascal's triangle, like the NCR things. What do you press again? Maths, yeah. Then where do you tend to go? Prob, yeah. Prob. And then, yeah, the third one is NCR, is it? NCR. Math Prob NCR. So now use this method to find the 2nd, 5th and 8th values of the 10th row of Pascal's triangle. And what I can do is, we have the 10th row on our front page. I believe so. So I could, try to think what numbers would have to go up here. Let's see, so you might need to have a particular number here. Oh, well, basically I forget they write it as NCR. So you would have to have 10, and feel free to try it out, and I'll show you, have this page up here so you can see if you got it right or not. So you might want to experiment a bit first. And I'll beam it up so we can see the 10th row. 10th row would be with the one that's got 11 numbers. Is that 1, 2, 3, 5, 10. I think it's this one. 1, 2, 3, 5, 6, 7, 8, 9, 10. I think it's this one here. Does the first one count?
Is the first of the single one kind of the row?
No, in a way, yeah. When we're looking at this one, it's as if this one at the top, the green one, doesn't exist.
It doesn't.
Yeah. Yeah. Is it down here? Yeah, 10 here. So what I'll do is I'll put a little yellow line here, just so you realise it's this row. So feel free to have an experiment with doing that, with using the calculator. And then you can always just look up and see, did you get those numbers? And I'll put a little yellow arrow. Oh, good, I've got one here.
Yeah. No, because if the one, does the one count?
That is like 10-0. So like if you were to put that in the calculator, it's like 10C0. So the first term is, yeah, like 10C1. would be 10, yeah. So that's interesting, isn't it? Like the first term, you put in 0. For the second one along, on Pascal's triangle, you put in 1. So that's a confusing thing, actually. People get confused by that.
Yeah.
Yeah, so for the second one, you're probably putting in 10C1, because the first one would be 10C0. So you might have realised when you put in 10C1, you weren't getting 1. Or when you're putting in 10C2, you weren't getting 10.
Okay, so we're supposed to get 10?
Yeah, we're supposed to get 10. For the second term, we're supposed to get 10.
Oh, but we don't.
Yeah, so if you put in 10C2, you don't get 10. So that is a little clue that you put in 10C1. So the first one would be 10C0,
Okay.
10C1. So it's almost counterintuitive. So it's something, yeah.
Oh, so the second term is actually 10.
Yeah, the second one is 10C1. Did you notice when you put in 10C1, you get 10?
Yeah.
Because I was expecting that most of you would start with 10C2 and realize, oh, I don't get 10. But we're supposed to get 10. So 10C1 is what you would enter to get the second term. To get the first term, you put in 10C0. It's a faster way to get to 10 NCR.
So we have to put in 1 before the term that we want.
Yeah, yep. What did you do? Oh, that does it too. Oh, is that factorial? Does it? So it does. Nice. So just letting people have a little experiment.
Miss Lonnie, how do you write it in the bracket?
What do you write in the brackets?
Yeah.
You write 10 at the top, and underneath it you would write the number 1 for the first one.
So it's the row that you're trying to find out on the top and then the term.
Yeah, so what's interesting is if you want the second term, you put in 1 on the
So you
bottom.
put 1, you put the number before the term you're trying to get.
Yeah, so normally we'd have NCR on our calculator, and what goes here is the N, and what goes here is the R. Yeah, so instead of, quite often the textbook and the exam questions write it like that. So in our calculator they write NCR. So in my notes I'll do a mixture, a little bit of a mixture of both. So it just means the 10 would go there, and the 1 would go here, if we want the second term. So if we want the fifth term, what would these two numbers be? If we want the 10 and 4, yeah. And the thing to remember is the first one is 0. 10C0 will give you that one. And it's all, it makes sense because there's 11 numbers. So to get to 10C10, that's going to be here. You're going to start 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's why the first term has to be 10C0. So that the last one can be 10C10. 10, 10. There's 11 terms in total. 11 numbers. So maybe let's go, now we can fill them in. No, on the wrong page. Here we go. Yeah, sure thing. So you've probably realised already, to get the second term, you've got to put in 10 and 1. So the way it would appear in your calculator is finding 10C1. If it helps, right above it, 10C1. So 10C1, hopefully it gave you 10. Because that should be the second term according to Pascal's triangle. I probably should have written more here. Fifth term, we would have to find 10 and, you said 4. That's like finding 10C4. What was that again?
210.
210. Okay. And to find the 8th value, would I do 10, 8?
10, 7.
Yeah, exactly. So that's another little common mistake. People forget that a lot. And it's all because there's going to be 11 numbers, and we want it to end on 10, 10. So that's why we start with 10C0 for the very first one. 10C7. What's that equal? What number are you?
120.
120, thank you. 120. So that's using the calculator. And this nice formula with the factorials is another way to find these values. Try it out. So same thing, we're just going to write in, for example, notice n, so top will be 10 factorial. We'll just write 10. We won't write out 10 times 5, 10 times 9, and so on. We can just write 10 factorial for now. Just practicing using the factorial button on your calculator. That's purely what it's for, this little drill. So same numbers as above. 10 and 1. So obviously n is 10, r is 1. So n equals 10, r equals 1 in this case. So equals 10 factorial over 1 factorial, which is pretty obvious what that is. And then 10 minus 1 factorial. It's fine if you change that to 9 factorial, because 10 minus 1 is 9 factorial. But I'll just put it in like that to begin with. And this is just practicing using a nice fraction button, like how do you make nice fractions on the calculator?
Alpha y equals.
Yep. Alpha y equals, and then select n/d to make nice fractions. Then it'll set up a nice fraction, and then we just want you to practice bunging in the factorial sign. So maybe doing that alpha f2 is a faster way to get to factorial. And hopefully you get the same numbers. In a way, we're just proving that this formula gets you those numbers too. And that is above 210. Give you some time to do that. Just manually plugging into a calculator sometimes helps you remember this formula to begin with, how to actually remember the formula, and how to find the factorials button. So if you forget, like, just try to remember this is kind of, binomial theorem is a style of probability, so it might remind you, it would go to math probability, or if you remember to go to alpha f2, that could also be good. Way to remember. Any questions about that? Like anything, were any of you not getting those numbers? So Isabella, we've just been manually using the formula and practicing using the factorial button and writing nice fractions. That's purely what this drill was, just a drill to help us remember what the formula is to begin with. Even though it's in the formula booklet, you don't need to memorize it. But maybe practicing what goes where, like the fact that the n is the top value and the r is the bottom value, and where is how to get to the factorial button on the calculator. So the next the next challenge is we're going to practice finding these binomial coefficients, but using the formula non-calc. So notice I've given you numbers that aren't really high. I haven't given any 10s or 9s or anything like that. Probably the worst is this one, but it's going to cancel down to something really basic anyway. You'll find you can do a lot of cancelling down sometimes too in the fraction. So what was that formula again? I thought a little bit of space so we can practice writing it. It's n over r equals factorial bottom and r factorial n minus r and then the factorial of that. When it's in the formula booklet, you don't need to memorize it. So our n is 4, our d is 1, our r is 1. You might want to just write it out first like that. It's going to be 4 factorial over, easy enough, 1 factorial, and times by 3 factorial. So if you want, you can just, rather than put in 4 minus 1, you could put like times 3 factorial. Or put a multiply sign if that makes it a bit clearer. Which you can write out the long way. 4 times 3 times 2 times 1 over 1. I'll leave them in different colours. So you can sort of see the factorials. 1 factorial times 3 factorial. Notice they're all being multiplied. There's no adding or anything going on. You could just work out the top and bottom. You can sometimes cancel down. Maybe let's just work out the top and bottom for this example. What's 4 times 3 times 2 times 1? Is it 90? Guessing 24. 1 times 3 times 2 times 1. 12. 6 could be so we've got 4. The other method is you could have cancelled down 1, you could have cancelled down 2, and you could have cancelled down a 3. And just done 4 over 1. So as you get to the higher powers, that might be an easier thing to do. Do some cancelling down. And particularly when you get to ones like that. That's going to save you a lot of time if you cancel down instead. So I'll start to look through these. 5 factorial over 2 factorial. 5 minus 2 factorial, which is 3. 4 times 3 times 2 times 1. Whatever. 2 times 1. So you might prefer to cancel down. 1 and 1, 2 and 2, 3 and 3. And if you want to, you can cancel further, but I'm just going to leave it as this. 20 over 2. Did you get 10 for your answer? So that cancelling down method can be helpful because they're all being multiplied. So that's why you can cancel down. They're all factors. There's no adding going on, subtracting. So what's your 3C0, 3 over 0. What's your prediction that the answer is going to be? 1, yeah. What would this one be? Yeah. This is like the first term and this is like the last term, isn't it? So I'll start to write it out fast now. Got this 0 factorial, and then 3 minus 0, yeah, 3 minus 0 factorial. But I'll still write it. Don't worry. 0 factorial is not exciting. But 3 factorial.
Wait, what happened to the 0?
0 factorial. Yeah.
0
Just like 1, yeah.
Oh, 0
So maybe I should write that in there. Maybe I should do that actually. So just say 1 times. That should probably be there. I just got lazy and skipped it.
Because you can't divide by 0.
No, exactly, yeah, because that would mess things up. Then it would be undefined after that. But we know that this should equal 1, because that means the first term in Pascal's triangle row. If you don't like it written like that, just rewrite it like this. 6, 4. It's the most common way to see it, but the textbook sometimes writes it like this, so I thought I'd give some where it's written like that. 4 factorial, 2 factorial. Yeah. 6 times 5 factorial, 2 times 1. Cancelled. 3, 4. And then you ended up with 6 times 5, which is 30. And then 2 times 1, did you end up with 15? I think so. What do you predict 77 is going to equal? 1, yeah. So you probably find the factorials cancel out. N minus 1, N minus R is 0. Yeah. It's a long way to prove that. Now we've got a few little challenges.
And then that equals 1.
Yeah, yeah. So I was just being lazy and skipping off 0 factorial before, but now I thought, okay, I should write it in. Some extra challenge problems. N factorial. Remember Talise and Paige, I think, came up with a suggestion. These are just asking us to simplify these fractions. Just practicing factorials. How can we write a formula or an expression for that? Yeah. And then it's fine to do point all over n minus 1. What would be the next term in that factorial? Yeah. I'll just put a few dot, dot, dot. Is anything going to cancel out? That and that. What does it simplify to? Yeah. That's bizarre. That thing just breaks down to be 1. I mean, not 1, n. So the n of I. N plus 2 factorial. So this first term is n plus 2. Get rid of n plus 3. No, it's not. Yeah, exactly. We're subtracting them. You could put just n if you want. I'll put it right. No harm in putting in brackets, really. What can we cancel down from the top? And yeah. And all the things at the top is isn't it? And put it up. So what is it? Yeah. Just kind of like make an expression. Imagine they wanted it kind of for it to stand it out too. What would that be? Finally simplifies. No, does it? It does.
And it's going to be
Yeah, so be aware that probably it's a simplified problem, so they probably want you to take it to here. That's the simplified one already. So these are the slightly more challenging ones. This one's trying to make it a bit more real worldy and trying to get wordy as well. Consider the cube alongside, which has a side length of a plus b. Oh, sorry, yeah. So this one has a side length of a plus b, and see this side length is a plus b, a plus b. It's a cube, so all side lengths are the same. The cube has been subdivided into 8 little blocks. They're all different kind of sizes. 8 little blocks by making 3 cuts parallel to the cube surface. So they've cut here, they've cut here, and they've cut here. So they've made 3 cuts. We know that the total volume, of course, has to be the side length cubed. So the total volume has to be a plus b cubed. However, we can also find an expression for the cube's volume by just separately adding up the volumes of the separate little blocks. Things to think about. I could start this off. Is anyone still writing that? Okay. How many blocks we'll have the dimensions A by A by A, just by looking at the diagram. A is that length there. I haven't even thought about the answers to this, by the way. Would it be the one, this one here? Or would it be the one kind of over in this corner here? Doesn't really matter. Do you think there's just one? What did you think, Paige? I can't even remember the answer. A is the longer length. Yeah, it's just, would it be just the one right at the very far part, but that we can't see? That? Or that?
But aren't they all the same?
See, this one's a skinny one. This one's like B by A is that one there. This little baby here is B by B. Yeah, it's one we can't see, isn't it? Because it can't be that one, because that one's going to be A by B deep, because it's going to be that high. So I think it's the one you write, like right at the far back that we can't see. So it's still just one though, isn't it? Maybe let's just write where it is. We can't. I was going to shade it, but we can't shade it. One at the very back. At the very back and bottom. How many will be A by B? So 2 longer lengths and 1 short length. I can see 2 at least, yeah. Would you agree this one's going to be? What about this baby?
Yes.
Will there be one at the back as well? Will that be one? You got 3? The ones at the back are going to be A by A at least, aren't they? The one at the back bottom is the A by A by A. So would you agree it's this one, and this one? Yep. So maybe as a note we can kind of shade that. Shade them. This one, and this one. It's like we have to imagine it all in 3D, don't we? So, getting something that we can cut up like this. How many will be? That was A by A by B. A by B by B. So 1 long side and 2 short sides. Yep, 3 again. Is there this one? Maybe this one. So 3 of them. How many? We can probably guess. There's 8 blocks in total. How many are going to be B by B by B? Just 1. One of the one here. 1 of them. You don't need to write of them. I don't know why I did.
Where's the first one?
The very first one is right at the very back bottom that we can't see. So see, directly opposite, diagonally opposite this blue one here. But it's at the very back. So that's why I wrote at the very back and bottom kind of thing. So the far back corner, but down below, because it's going to have that length, and it's also going to have that side length. It's going to have this height, this width, and that side length. And so it's right, like directly opposite kind of here, through the box. So in total, that's good. They add up to 8, because it's meant to be 8. By adding of the volume of boxes, can you find an expression equivalent to A plus B cubed? So the green one, what would be the volume of the green one?
Big cube.
Yeah, probably it's really fast. What would be the volume of one red one?
A squared B.
Yeah, B A squared B. And what would be the volume of blue one? It's going to be 3 of them.
3B squared. And A squared.
Yeah, that's right, yes. Algebra gods for some reason like it in alphabetical order. B squared A, technically right, but they algebra people just like it in alphabetical order. And the last one.
B cubed.
And what we can do is, for a warm-up next lesson, we can do a binomial expansion of that, and it's the proof. You might have done it already, so, but to finish up the proof, we could just go as a warm-up. Thank you very much. Can you bind it?